Kara, welcome back.
Absolutely. It's great to be with you. And always enjoy our conversations. In fact, just as you and I were talking about, you've, sparked a thought with me on a number of occasions to, dig a little deeper into the research from, those interesting angles that you bring forward. So glad to be back here and do some more digging.
Well, thank you so much. And I'm so excited to talk with you about your new book, Younger You, because the big meaty topic in the book is methylation,
Mhm.
which is near and dear to my heart. Our listeners are
Yep.
probably tired of the story, but I have a problem methylating. I am the MTHFR gene, double C677T, a sky high homocysteine, brought it down through supplementation, and it's healthy level now. But at any rate, bringing it back to methylation, you say methylation is the key to aging. And so obviously I picked up
Right.
this book. I'm like, whoa, 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 I'm good. All my markers are good. I got to get I have problem methylating, but like I feel like I look good, I feel good, the markers are good, but this one I can't get under control. So I'm like, all right, we have to talk about this. So before we get into me and the genetic freak that I am, although there's a significant portion of the population who does have the MTHFR gene. You start the book with a pretty big promise, a pretty powerful statement. What if I told you you could be younger tomorrow than you are today? So, what would the answer be? And I say, yes, I think we're all interested. If you entered a cocktail party and said, what if I told you you could be younger tomorrow than you are today? So yes, we're all interested. So at the highest level, how do we all do that?
Yeah. So it turns out that aging, which I want to say is the biggest risk factor for all chronic disease. So if we can actually crack the aging nut, if we can actually get biologically younger, we're not going to get chronologically younger, but if we can actually get biologically younger, make our physiology that of somebody, at least a few years younger than who we are now, we stand to change the trajectory of the globe, really, if we can get a little younger and a little healthier, or maybe even a lot younger. Studies are starting to show that's possible. I think the extraordinary thing about our study, and I would love to talk to you ad nauseum about how we even came upon this, and we can if you're interested. The extraordinary thing about our study that's unique in the published literature at this point in time is that we showed that in 8 weeks' time, all the studies out there to date are longer and generally much longer, like a year duration or so. In 8 weeks' time, with a diet and lifestyle intervention, with a doable diet and lifestyle intervention, I might add, we reversed the biological age of our participants as compared to the control group by over 3 years. Yeah, it's pushing us into really kind of the next generation sort of stratosphere of where medicine and our medicine, functional medicine in particular, is going to be putting attention and how we're going to be shaping research. People are going to want to be including measuring biological age. Should I tell you about it, like how we did it? Or
Yeah, yeah, please do.
so the way that we measure biological age is by DNA methylation. We're methylating all over the body and all of our cells all of the time. You're familiar with it, metabolizing our estrogen or, helping us to make dopamine or, adrenaline, et cetera, getting rid of toxins. Well, an exquisitely important, less appreciated role for methylation is in regulating gene expression, which genes are on and which genes are off. And there's a handful of different ways that we do this in the level of our genetics, but arguably certainly the best researched, best studied, and arguably the most important is DNA methylation. And so there's these DNA methyl transferase enzymes that literally put that little methyl group, carbon with three hydrogens, down on promoter regions of genes. That is the region of the gene that will allow it to be turned on or off. When you've got a lot of methyl groups, just in science, they're always denoted by as looking like red lollipops. So you'll see this double-stranded DNA, if you can kind of visualize that, and you'll see a bunch of red lollipops in one little area. That's, the promoter region being hypermethylated, and therefore that gene can't be turned on. Those methyl groups just get in the way from transcription happening. But those methyl groups can either be inhibited from being put on, or they can actually be plucked off by a family of enzymes called 1011 translocation enzymes. So we can intentionally remove them using enzymes, or we can also intentionally inhibit them. Actually, toxins can get in there and inhibit with them. There's all sorts of things that we can get in there with and gunk up the works. So it turns out that as we age, there's a predictable pattern of havoc that's wreaked on epigenetics, on DNA expression, on DNA methylation in particular. So we can really accurately predict somebody's chronological age by looking at DNA methylation patterns. We can also predict their, you know, morbidity and mortality, like time to death, looking at DNA methylation patterns. And we can actually do it across the course of a life. You can look in utero at DNA methylation patterns, and you'll see that the embryo is negative. It hasn't been born yet, so its patterns would put it chronologically at a negative number. And then in early childhood, we're actually developing really rapidly, as we're supposed to. I have a toddler now, and she's just gaining new skills by the second, and so she's aging actually really fast. She's supposed to be. And then move on through life, and things start to change. Menopause comes in, or we hit, adolescence and sexual maturation, and then menopause, and then aging. And what's extraordinary about the aging journey is that the imbalances that occur appear to be pretty predictable. And I mean, the new thinking in science is that aging itself might be a sort of programmed event, in directed by DNA methylation. And so then the rationale is, if you go in there and really optimize DNA methylation, stepping out of the larger methylation conversation, but just really narrowing in on DNA methylation, can you reverse biological age? And we set out to answer that, and our findings extraordinarily were that yes, we could, and in a short order of time. And we'll continue to research it and tweak our intervention and maybe do it longer, et cetera, et cetera. But let me just take a pause there and see what your thoughts are.
In terms of what we keep on coming back to methylation and methylation being key in the aging process. I used to be under the impression, I'm not after reading your book, is that homocysteine was the way, if you if you did not properly methylate, on one hand, your homocysteine would be elevated would be greater than 15. Ideally, you want it under 10, and then, or you're not properly methylating, it increases significantly, or it's exceptionally low. And so I was always under the impression that was the methylation score, if you will. And if you had the
Mhm.
MTHFR gene, which, was it half the population does, you might be more prone to a methylation issue. And if you had specifically the C677T gene, which I do twice, if the double gene, like, you're probably even more problematic. And I've told the story a zillion times. Mine was 63. I got it down to 12 through supplementation. And now I'm just stuck in this range. And I'm like, all right, it is what it is. I don't think anyone, I was joking before the show. It's like, all right, we could all aim to get every, marker, every lab result perfect. And then, we'll walk out and get hit by a bus. It
Right,
just,
right.
so with that said, how do we know, other than, how do we know where we stand in terms of how we're methylating? And if
Yeah.
we're doing so in a way that's you would deem to be healthy and beneficial for health span longevity.
I've got a few things to say on it. I think that those of us in this field have been just, there's a bunch of bright human beings who are drawn to integrative medicine, and we've studied biochemistry, and, it's everybody knows the methylation cycle, and the transsulfuration cycle, that homocysteine can be shunted into glutathione synthesis. It's kind of extraordinary how much we've learned. And a lot of us have gotten our genetics. And, the promise was that if we address our genes, if we address the methylation cycle, that we could really, change our health trajectory in a rather extraordinary way. I was very buoyed up about this possibility back when I was in the lab. You know, I mean, almost 20 years ago now, but when we first started to look at single nucleotide polymorphisms and methylation cycle intermediates and so forth. And I got in there and played with it for a long time. It didn't bear out sort of the promise for 99% of the folks I worked with as, as we anticipated. Uh, there had to be something more. And I think so I do think considering the methylation cycle is important. There's no doubt about it. I think considering MTHFR does have its place, and make sure I talk about MTHFR and aging because in case I miss it. So I do think there's some importance, but I think we've been a little bit myopic in how we think about methylation by placing so much importance on that cycle and so much importance in the potential for, you know, genetic variants. If you zooming out and thinking about genetic regulation and methylation there, you'll see that there are far more players in the pond. It's not limited to B vitamins and some minerals and so forth. It's Yeah, we need a robust methyl donor intake and arguably in a food matrix for reasons we can talk about. But we also need to direct the behavior of these methyl groups. So we need to bathe ourselves in methyl groups, as you know, but we don't want them to just we don't want to just push methylation forward. We want to give information for where they go. And that was a massive aha for me in doing this research, realizing that you know, polyphenols that we've been consuming that as humans, time immemorial, like curcumin or green tea or rosemary or shiitake mushrooms. There's just, on and on. The colorful, you know, polyphenol, the sort of the dark matter it's sometimes referred to of nutrition because it's not a vitamin or mineral. It's, the regulatory stuff. And anyway, I could go on and on about it. It turns out that in us, these exquisite compounds direct methylation traffic. And so you want an abundance of methyl donors, but you want it with traffic directors, with these, we're calling them methylation adaptogens, but I'm actually just describing both of them as epinutrients. They're epigenetically active. So there's this dietary portion. And I'm telling you, I think one of the reasons, I actually think a really big reason that we made a difference in 8 weeks' time is because we very intentionally bathed the body in a high amount of epinutrients. When you look at other studies that like incorporating the Mediterranean diet or just looking at healthy eating patterns like DASH and a healthy standard American diet, whatever that is. But when you look at studies where they were analyzing that in relation to biological age, there is a benefit shown, which is fabulous, but it's very modest in compared to what we did going right after DNA methylation. And I want to say it's more than just diet. Exercise influences methylation, you know, as potent as a methyl donor, as potent as a methylation adaptogen, adequate sleep, stress management, some intentional stress management practice influences methylation. And I don't think we've appreciated that, a healthy microbiome and, it just kind of an on. So, one of the other things we did was really zoom the lens way out and embrace variables or signal molecules that influence methylation from a far broader perspective.
Let's go there because you break it into a couple different groups. In the book, you say methyl donors plus DNA methylation adaptogens plus lifestyle, which you touched on all of these kind of briefly just now, equals a younger you. So if we let's start with methyl donors. Talk about, you know, what we can do there.
Yeah, so it's the classic foods people are probably aware of. A lot of leafy greens, as really as much as you're willing to consume. Our program recommends about 7 cups of veggies in total, so not just leafy greens, but cruciferous.
7 cups daily.
Yeah, if you can do it,
Okay.
about 7 cups. So staying on the methyl donor track here, seeds, pumpkin seeds, sunflower seeds, nuts, but seeds are more nutrient dense as far as methyl donors. Beets, doing a couple of beets daily. You don't have to go crazy with the beets. I know they're pretty sweet. And for people with blood sugar sensitivities like me, I need to be mindful about overdoing it. But beets are loaded with betaine. And as you know, that's a methyl donor. Eggs, we want to be eating 5 to 10 eggs a week. So we don't want to shirk away from eggs. We're not going crazy. You don't have to have eggs every day, but you want to be getting enough of that all important choline, which is another important methyl donor. Liver, a few days a week, if you can either cook liver and eat it and enjoy it, which the participants in our study did actually. They developed some pretty good recipes. One guy called them the sort of like the alternative chicken nugget. He came up with this sort of paleo way to prepare them. Or if you're like me and you're not cooking liver, there are very exquisitely clean source liver caps that you can get, like New
Yes.
Zealand liver, and that's what I'm doing. It's just easier. And I liver is an extraordinarily important food matrix. It's a multivitamin in a food, and it's what we used before we synthesized B vitamins. You were prescribed liver. Maybe you were given liver injections if you had pernicious anemia or, a B12 neuropathy or something like that. I mean, it was our go-to. I think the whole food matrix has I mean, I don't think, I know there's so much more information surrounding that nutrient. It's just smarter for us to give that whole food package that and multiple foods like you would eat in a salad. That complex sort of bite of information is extraordinary. And I think that it's a potentially very important director of gene expression traffic and particularly DNA methylation.
So going through all the foods, you go through the book, you have, a great yes list, a great no list, if you will. There weren't many surprises, basically whole foods, plant-based, avoiding processed carbs, avoiding sugars. You do call out monk fruit, which I love, works well for me as a sweetener to enjoy. The ones that stuck out, but this isn't, I guess, surprising because a lot of people have feelings around lectins. Bananas, peanuts. I was like, okay, uh, not surprising.
Yeah, but I wanna say that that was the 2 big criticisms or questions that I was asked after the study came out was, "Why no beans?" and "Why aren't women in the study?" Maybe not in that order. I'm a huge fan of beans and legumes. I think that
Yes,
we know long-lived individuals are loading up on beans. People who are alive now and just doing very well, healthful individuals now are eating a lot of beans and legumes. So, we introduced them in when you transition onto the everyday program, the maintenance program, you're back consuming beans. If you're a vegan and you're doing this, then we want you to be consuming beans. The we just You just need to be mindful. So we were really wanting it to minimize glycemic cycling. So we wanted it to be lower carb, and beans can for some, myself included, just turn my blood sugar up a little bit more. So, just for this period of time, this 8-week period, you don't have to adopt this as a permanent lifestyle by any stretch. You're off of things that might nudge blood sugar negatively. And yeah, certainly a subset of individuals will have, gas and bloating with bean consumption. And even smaller subset, really small subset, maybe lectin sensitive. So,
right.
for those reasons, we pulled the legumes out or the lectin. It's a low lectin diet. There's some intermittent fasting. I mean, we think we got our participants into ketosis just because their triglycerides dropped pretty considerably, but they have a modest exercise prescription and so forth. So we were kind of hedging our bet more towards that direction than, making a commentary on lectins.
Right, right. I eat beans, I love beans, but for me to minimize the blood sugar spike, I'll always, have an avocado with my beans with, like, some
Yep,
olive oil, and that's it, I'm good. And
good.
agreed, I think everyone's over, look, for some people of serious autoimmune, lectins are the answer, removing lectins are the answer, but for most, I think there is consensus that, people who consume a lot of beans are some of the healthiest people in the world. So moving on to like the food's not surprising. Essentially, it's a pretty close
Yes,
to a plant-based keto diet with some
yes.
healthy meats, but there's not, other than liver. I'm like you, I just can't do liver. Like, and I'm someone who has an affinity for meat. Like, there's nothing like,
Okay,
a great grass-fed burger
sure.
or, pasture-raised pork ribs. I don't do them all
Yeah,
the time because heart
yeah.
disease runs in my family, but I do them every once in a while, and it's amazing, but I just can't do liver. But
No.
it's essentially plant-based keto. If I were to
Yes.
summarize,
It is,
it's
but
close.
I really it is, but I have to underline and underscore big time that it's designed for methyl donors and methylation adaptogens in a very intentional way. So if somebody were to say, "I'm gonna pick up, Joe's book on a plant-based keto," I we certainly wouldn't promise the same outcome.
Yeah, because 'cause they're not saying load up on beets, but for you, you are. I take a beet powder, by the way. So, in terms of so you got your methyl donors, and then you talked about this briefly. If you could talk a little bit more about DNA methylation adaptogens.
Yeah, they're just these really. So again, it's the polyphenol, it's the family of polyphenols. By the way, I have the a galley copy here of the book, and we just have if for people who are drawn to this book, one of the coolest features is there's a nutrient appendix unlike any other, and it's, I don't know, a good 30 pages long, and the
Yes.
bulk of this nutrient it is, it's a huge reference. It's not your standard nutrient appendix. It is looking at epinutrients as a broad category. So there's a massive section on DNA methylation adaptogens, and then there's the methyl donor section, and then methylation adapt those the enzymes I brought up earlier, the 1011 translocation enzymes, the ones that actively remove methyl groups. There's a whole section on how to support those in a food-based way. So, methylation adaptogens, most of them are polyphenols. They direct traffic. They seem to have primarily an inhibitory effect on DNA methyltransferase, but it seems like, and most of the studies are in cell studies or they're animal. So, human studies, ours is, one of the earlier ones looking at this particular question. But when you look at the animal and cell studies, they seem to be pretty specifically going after genes that have been shut off and are promoting a disease because they're shut off. Most classically, we're looking at tumor suppressor genes. In cancer, we actually started the DNA methylation investigation in our clinic because I was reading the literature on cancer epigenetics. The tumor microenvironment very efficiently hijacks the epigenetic machinery, so hijacks those enzymes and takes over our gene expression. It's crazy. So, a tumor microenvironment will shut down genes we want on, protective genes, and turn on genes that promote disease. So, classically, cancer shuts down tumor suppressor genes, shuts down those all important good guy genes that surveil us and keep us cancer free. Cool. Actually, let me just say one thing about this. When you look at cancer as an entity and you look at the changes that happen in DNA methylation, you actually see that pattern of dysregulation is happening in all the chronic diseases and aging itself. So, in aging, and this is why it's the biggest risk factor for chronic disease, for example, the tumor suppressor genes are hypermethylated and shut off. So our cancer surveillance system is shut down in aging itself. So the literature looking at tumor suppressor re-expression and polyphenols is just really kind of cool and beautiful. And there's a whole actually, so in addition to this appendix that breaks out a lot of these polyphenol compounds, there's another table looking at tumor suppressor genes and the polyphenols that have been shown to re-express them. So we know EGCG, equal, genistein, we know anthocyanin, diindole methane, ellagic acid, curcumin. So these are the reasons we're eating blueberries or strawberries or turmeric or cocoa or coffee even. Garlic, ginger, what else?
You mentioned curcumin and ginger.
Yeah.
Those are 2 great ones, which I love. I'm curious when you talk about consumption, when you mentioned dark leafy greens, you 7 cups a day, which is significant. And so I'll just take curcumin and ginger. How much do we need to consume to get
Yeah.
the benefit?
In our study, we just recommended like a simple half teaspoon of
Okay.
curcumin, and we didn't put recommendation in ginger. So we want you to do in the foundational study, um, sort of the targets that we want you to hit, include a couple cups of green tea, a little bit of turmeric every day, the vegetables, the beet requirements, the weekly liver and egg requirements, and some seeds. I mean, it's really relatively basic. That's the core targets that you need to hit. That's not going to meet most of our caloric requirement, so then you're gonna
Right.
layer in other foods that are legal, and in that case, you can turn to the nutrient appendix and just dig in, with these beautiful additional foods.
So just liver again, you mentioned, I mentioned, we both don't eat
Yeah,
liver, and I think
yeah,
I'm gonna guess that the majority of our listeners probably don't eat liver, and so if I'm gonna go out, this is an area. Look, food is medicine, and that's our point of view. Always start with food first, and if food doesn't work, you need to supplement. Supplements can
yeah.
be, big believer in supplement, but start with food first. So like for liver specifically, if you're just shaking your head saying I can't do it, what should you look for? I'm curious in terms of what you look for in a beef liver supplement in terms of dosage, in terms of frequency. And I'm curious, like, is there a specific brand you like that does a good job?
Yeah, what am I using? There are a handful. We sussed them out and researched them pretty thoroughly, and we've got a resource section in the back of the book. I'm taking, is it Ancestral liver? I mean, I should see it. It's a clean New Zealand
Yep.
product.
I take the one that periodically from Allergy Research Group.
That's interesting that you're taking that. I looked at it and I think it's a pretty cool product, but it's not, you want it. They modify their product a little bit more. I didn't include it in our references, I
Okay.
think for that reason, and I would have to look back at it and see why, because I do think Allergy Research is a great company, and so this isn't a negative on them, but you just want freeze-dried, non-defatted liver. Nothing else. No fuss, no muss.
In terms of dosage and frequency, is it a daily? Is it once a
Yeah,
week? And
so if you ideally, you're doing about maybe 4 to 6 caps per day, and that will, at least in this product and the product that we cite in our resource section, 3 ounces of, liver per week. So, you could do it as a daily distribution. You don't have to, you could take more, less times
eh,
per week, but I'm in the habit of just grabbing 6 in the morning and, I can do fine with
got
them.
it.
They don't upset my stomach. I mean, it's a micro amount of liver, like 6 little capsules. It's like a
Right.
bite of liver.
Right. And which brand is this again? Sorry.
It's ancestral. I'm so sorry. I
Ancestral.
can
Okay.
see it over there,
All
but
good.
yeah,
We'll put it in the show notes.
put
It's
it in the link.
interesting. Yeah, we'll put it in the show notes. So in terms of we're talking about supplements anyway. I'll segue to
Yeah.
supplements. So, look, supplements are personalized, as I mentioned. For me, I supplement. I take lots of supplements. We have our own supplement line. I love supplements, and they've
Yes,
helped me
me too.
tremendously with my homocysteine. And so, without going down the rabbit hole, I do think they're personalized, and I know you agree, but you also, and we agree on this, you go in the book, you say, look, there are certain supplements that it's safe to say that pretty much everyone can benefit from. So can you walk through some of those supplements? You had an omega D. Just
Mhm,
talk a little bit about like some of the
mhm.
ones that like pretty safe to say everyone
All
can
of us are
benefit
gonna
from.
do, yeah, yeah,
Yeah,
yeah. So, in our study, we used a probiotic. We used specifically Lactobacillus Plantarum. The reason that we did, and we talk about species, genus and species that you could use, the Lactobacillus Plantarum, along with a handful of bifidotypes, may support the microbiome in making its own natural folate, and so it's another nice source of methyl donors. You can get, a good healthy gut is going to be making a lot of those vitamins for us, and so we had people use Lactobacillus plantarum. And of course, a good healthy gut is essential for many other reasons, which I know your listeners know, like absorption and biotransformation of our food, and also in epigenetic regulation, including DNA methylation. I think our gut microbiome plays a really important role. So, for many reasons, good gut is essential. The other thing that we used in our study, just again, talking about these DNA methylation adaptogens, is a greens powder, additional polyphenol information, just an organic greens powder. We used metagenics in our study, phytoganics, but we make additional recommendations in the book. So you're not beholden to use the products we did, although, I could see that people might be interested in that. But I think any good quality organic greens powder is good. It's just an additional, you know, bump. Yeah, all of us are deficient in omega-3. So we want people eating adequate amounts of omega-3 foods, be them vegetarian sources like flax and chia, or, nice fatty, good quality fatty fish. But even still, myself included, as much salmon as I eat in a given week, I still need more, and as much chia as I eat, I still need more. So I always take an omega-3, a good high potency omega-3. Vitamin D, yeah, we're all deficient. It's actually crazy, and I don't know why. It seems almost, well, certainly in my patient population and myself, it's pretty hard for me to keep my D up. I mean, I'm currently taking 10,000 IU, which is more than I ever thought that I would need, and my last measurement was 50. So, I think vitamin D is decent. What else did I cover? We actually did a broad sweep in supplements. If you're vegetarian or vegan and you need it, if you wanna be taking some iron, vitamin C is decent. What else? Zinc, a lot of us need. Magnesium is important. I talked about melatonin if you need support with sleep, but melatonin is also its own anti-aging and antioxidant molecule for a variety of reasons. I talked about specific pro-resolving lipid mediators as really interesting and important molecules that come from omega-3s. Are you familiar with SPMs? Do you have a supplement of SPMs, or are you thinking about them or talking about them at all?
Well, let's talk about them right now. But before we go there, I do think, you mentioned we have an organic greens, a D3 and an omega-3 I think you'll love. So after this,
Good.
I'll get your address and I'll send them to you because
Okay,
our
cool.
actually
You have a
our
probiotic, I'm sure.
we do different strains because it's not geared for the genetic freak like me. It's designed for bloating, but you'll appreciate them. As our audience knows, we have a phenomenal PhD RD on staff, Ashley, who actually used to be a formulator at Metagenics.
Oh, cool.
So you will love these formulas. We'll
Yes,
offline about it. But
good.
so let's
Yeah,
talk. So let's go there.
we're talking about SPMs.
Yes.
SPMs, okay. Or pro-resolving lipid mediators. Yeah, so omega-3 fatty acids, actually omega-3 and omega-6, the ones that can produce eicosanoids. So the ones that can be broken down into derivative molecules, secondary metabolites, are ridiculously important. We know eicosanoids because we know omega-3 produces anti-inflammatory eicosanoids, EPA and DHA, and then we know that arachidonic acid is broken down into the most potent pro-inflammatory eicosanoids, prostaglandins, and leukotrienes. So these are the reasons that we're taking a bunch of fish oil. A lot of us sort of have a rudimentary understanding around these two things. You don't want a lot of omega 6s because of the potential pro inflammatory push. You don't want a lot of the omega 3s, or you do want a lot of the omega 3s because of the anti inflammatory push. And that's kind of the extent of our understanding. Well, just moving like gangbusters in this arena, and we're learning that there are, hundreds of these derivative compounds, some just being characterized that do really important stuff, like DHA, pro-resolving lipid mediators, work in the brain. I mean, we think about DHA for brain all of the time. Well, it turns out there's these compounds, they're called neuroprotectants, and they really protect brain function, brain development in utero during pregnancy or in infancy. They also protect the brain after traumatic injury. You might have be familiar with some of the studies where they use massive amounts of omega 3s, and it's suspected that it's the DHA protecting brain. EPA has, its own massive cascade of these secondary compounds that are doing really badass stuff, quite frankly. They're resolving inflammation. So, and you know what? Arachidonic acid actually produces some good guy compounds as well. So, the name of these are pro resolving lipid mediators. And the thinking among scientists, kind of calling these molecules out and studying them, is that inflammation is a failure to resolve. Like the inflammation, chronic inflammation continues uncontrolled because we don't have enough of these resolving lipid mediators shutting it down. And that's basically what they do. There's tissue specificity, like I talked about neuroprotectants in the brain, but they get in there. You take your omega 3s that are housed in the lipid membrane in our cells. You break them down into these resolving lipid mediators and they stop inflammation. So it's a hugely important reason we want to be ingesting enough of these guys. Um, and you can actually take them now they've been stabilized and you actually can take these pro-resolving lipid mediators directly. You don't take them instead of your omega-3s. You still want your membrane packed with omega-3s, but you can take them if you've got an inflammatory event, like if you've been sick or, if you've got an inflammatory autoimmune condition or, whatever for the myriad reasons become inflamed, you could certainly use them. And I want to say one other thing because this is a topic near and dear to me. Some of us don't make pro-resolving mediators very well at all. People who've got diabetes, for example, some of us don't absorb them as well, and so there can be a reason early in treatment, like if you're just turning the corner on making really important lifestyle changes where you use these for a while. I'm just kind of bullish on them being a smart nutrient, and I take them daily along with my omega-3s and along with eating, a lot of fatty fish and chia and flax.
So we've talked about methyl donors, we've talked about DNA methylation adaptogens. Let's segue to lifestyle, specifically exercise. A lot of different opinions on what is the best. I've joked it's an old joke. People have heard it before, but I would say the best exercise is the one you actually do.
Right. That's exactly right. It's not a joke. True.
But from your point of view, if we're exercising for methylation,
Yeah.
what's the best exercise there? What should we be focused on?
Well, again, you just wanna be doing it, Jason. You're absolutely right. What's the habit that you're going to keep doing? Our study was such a modest prescription, 30 minutes, 5 days a week at a perceived exertion of 60 to 80%. So, you can do whatever thing that you wanna do for that 30 minutes minimum. You can go longer, and we want you to go longer, as long as you're at 60% perceived exertion, it's a little bit harder to talk, you're probably sweating a little bit, and then at 80, you're still able to talk, but it's harder, you're moving up there towards max. So, we have a little table in the book of how to determine that, and you can do whatever the heck you want, be it walking or riding your bike, you can clean your house, the guys in our study, a number of them they live in Portland, which is a real pedestrian-friendly place. They, at least 2, maybe 3 of them started to walk back and forth to work, which was an awesome habit, and, or walk your dog or whatever. You can go to the gym and work out if you want to as well. We wanted it to be modest. So I think that measuring biological age will be something that we're able to do with a high degree of frequency. And I think, ideally, we even have it in some wearable device in the not so distant future. I mean, we want it to be accurate. So if there's any wearable claiming bioage measurement, run. Run. It's only just recently left the research setting, so it's still evolving, and it's pretty involved to measure biological age. But exercise itself is very helpful in reducing biological age. Under exercising is going to have negative fallout. Over exercising, likewise, might push biological age forward. But my over exercise is not your over exercise. So when you're asking me, the entry into this conversation is what's the definitive answer? And the definitive answer is that it's individual. Well, that it's A, what are you going to do and be consistent? And B, that it's individualized and that there is some suggestion. We know unequivocally if you don't exercise, you're increasing your risk for disease, period. I mean, that's so strong, that data. And there's also suggestion that if you push it too hard, you're risking. You're an athlete, and I was a competitive cyclist when I was in medical school. At the end of every season, I got sick. I mean, we know classically you're like immunosuppressed when you're really burning the exercise candle at both ends. So you probably don't want to do that all the time. And some research does suggest that that can be pro aging. So, what's right for you? This bioage technology, as it's more and more available, will be able to determine what's right for the literature suggests, well, we wanted ours to be doable and we wanted people to stick with it, importantly. But I think the data on high intensity interval training is pretty strong. The data on, resistance training is pretty strong. So I want to say one more thing because it's really interesting. Exercise, I was talking about um, tumor suppressor genes getting hypermethylated in cancer and in aging. So our ability to shut cancer down, we lose that as we age. Polyphenols turn those genes back on and take care of us. Exercise acts just like a polyphenol. I mean, it's just so cool. It helps re-expression of tumor suppressor genes. This is one of the reasons we know exercise is potently anti-cancer. In fact, there was a study that just came out maybe in the last month or so saying that it's epigenetic. All the benefits of exercise are driven via epigenetics. So the more we understand benefits, we can sort of zero in, and we see gene regulation plays a big role in why things work. So we see there at the end of the line, it's very anti-inflammatory, but that's because it's, turning on anti-inflammatory genes. And then let me just add one more thing to this exercise study because it's just so, well, two more things because it's so interesting. The older we are, the more exercise bang for our buck we got at gene regulation. So if your excuse is you're too old, not only are you not too old, you're actually gonna get more bang for your buck the older you are if you get out there and move, which I just think is so, so cool. And the other thing, so if you're preconception, if you're, still gonna have kids, your exercise habits can be heritable. You can transfer some of those good habits on your genetics to your offspring. I mean, isn't that I think those things are so cool.
It's interesting, and it sounds like there's a bit of a fine line. You need to exercise, you need to push yourself, but if you do too much, that's actually
It might be pro-aging.
yeah, so
Mhm,
it's like it's a little bit of a fine line. Can't do too little, can't do too much. You gotta push yourself. It's like
mhm.
everything.
Yes, that's right. I came to that over and over. I mean, we go back to the B vitamin conversation, and just taking isolated B vitamins, I would argue, is well, what would I say? It's the fine line. It's a U curve. That's what we call it in science. It's a U curve.
Right.
So too little B vitamins are a big problem for everything. Cancer, birth defects, neuropathies, et
And
cetera,
then
et
too
cetera.
many, yeah.
Too many, there is some suggestion that they're problematic as well. And the strongest science around that is looking at cancer. So if you're just really squashing yourself with B vitamins, you may, if there's no reason you're doing that, you may wanna really rethink it.
Right, and I think it's a good philosophy for everything. Anything that's good for us is you potentially negate the benefits and do harm when you overload. Maybe not the best example, but, like, eating too much spinach
Yeah.
can cause kidney stones.
Yeah.
It contribute to there are a
Yeah.
lot of
Yeah.
factors happening there, but just in general, like, you just
Yeah.
have to like, anything that's too much in when we talk about orthorexia and getting excessive,
Yeah.
there are you're doing potential harm or at the very least negating some of the benefit.
I agree. Yeah, that's right. You wanna mix it up.
Yeah, you gotta mix it up.
And really, you know what? Have kind of a rationale for why you might be doing something. Like, think through your supplement protocol periodically. I'm doing this for this and this or this. So we're not getting into, just habits. Like my dad will send me a picture of his supplements, every 6 months or so, and he has no idea why he's doing things. And
100%, and you're speaking I love supplements. We have a supplements business. Supplements, getting my homocysteine down was potentially life-saving, but it's important to pare down. You always pare down. You don't wanna get to a place where all of a sudden, "Oh, wait, I'm taking 40 capsules," or whatever. It's ridiculous. So you should always be optimizing and, ask yourself, "Can I cycle off of this? Can I potentially have a food?" Or do I really need this? How do I feel? And it's just important because I get that for some people, very quickly you can just, you know, build a cabinet that's just overwhelming, and all of a sudden it's you know gets to a place that's not exactly healthy. In closing, I'm curious. You're on top of all the latest and greatest science, and I think the biological aging conversation is a conversation that's beginning to happen, and a lot of people are excited about. How do you see that conversation specific to biological aging moving forward in the next like couple years? Like, what is that going to look like, and how
Yeah.
accurate, how nascent is it? So like,
Mhm.
are we still so early? Is it going to be
Mhm.
somewhat accurate, really accurate? And then where's that going in your opinion?
There's ridiculously interesting science coming out. I wanna just point to David Sinclair's lab at Harvard and what his team is doing. So Using altering DNA methylation and demethylation, they push aging forward in an animal model, so they cause aging. In fact, in one study, they induced an age-associated optic neuropathy in mice. They restored it via changing DNA methylation and demethylation. So they pushed aging forward and then reversed it, both total aging in an animal model and one specifically related to vision, and changed it around via changing DNA methylation. So I think its importance is just being really unearthed now in the aging conversation and understanding aging. I think for the radical biogerontologists, I'm a clinician. I'm looking at diet and lifestyle. That's my area of interest. But there are conversations out there, on drug development. There's billions and billions of dollars, like Jeff Bezos and just sort of the Uber billionaires out in Silicon Valley, or probably Uber actually, looking at, the drug that's going to change this. It's so crazy. And the first person to live to 150 or more is alive today. So they're looking at some wild stuff. But then there's us who are down to earth. And I think, our intervention is totally safe. It's healthful and it seems to be able to favorably alter epigenetic expression. So it is nascent, but it's real, and I think it's going to grow, and I think we're going to understand it more, and I think we're going to be using it more. I think it will be a important area of investigation for all of us and not just in the research set, and I think that will be soon. A piece of or a massive barrier is that it's expensive. I mean, when we started our study in 2017 and we ran it in 2018 and 2019, one test was, I think, $1,200, and we got 3 different tests. So just the testing alone was, almost $4,000. Now, you can get that same test that we use in the neighborhood of to in the research setting of maybe 200, to $400. But that's still way prohibitive for most of us. So I think as the technology evolves, the price will come down. There's a really cool cancer test called the Grail. For anybody interested, we've got a post on it at our website that detects 50 different cancers, and they do that via DNA methylation in blood, so cell-free DNA methylation. If you ever get the Cologuard test, for example, people get the Cologuard these days instead of a colonoscopy. That's looking at DNA methylation. It's here to stay. There's no question about it. No question about it. It's going to evolve and grow more sophisticated, but it's a tool in our toolbox that isn't going anywhere.
Fascinating. Kara, thank you so much.
You're welcome, Jason. I look forward to our continued conversations.